The video lecture for section 3.4. This is for MGF 1106. My name is Jorge Gabriel. So section 3.4, we're going to be verifying arguments. We're going to use truth tables to show an argument to be valid. We're going to also use truth tables to verify arguments. We're going to recognize some common valid argument forms and then also recognize some common fallacies. So an argument is a series of statements called premises followed by a single statement called a conclusion. Now, an argument is valid if whenever all of the premises are true, then the conclusion must also be true. So representation of arguments would be, here we have the first one, if P then Q and P, therefore Q. And so if the first premise is true and the second premise is true, then the conclusion is also true. And then when you usually, in this section, you usually get it looks like the one on the left. And then probably the easiest thing to do is to write it like the one on the right and then go ahead and construct the truth table. But sometimes you can see it and there are some forms, and as long as you can say that it's the same as one of these common forms, then you don't have to construct a truth table. So how to verify an argument: make a truth table with separate columns for each premise and the conclusion. Or if it's one of the forms, you can skip this. Examine only the lines in the table in which all the premises are true. If the conclusion is also true for the lines you examine in step 2, then the argument is valid. If the conclusion is false for even one of the lines you examine in step 2, then the argument is invalid. So here's the first one. Determine whether the following argument is valid. If you buy the more expensive Hulu plan, then you can watch TV commercial free. You cannot watch TV commercial free, so therefore you did not buy the more expensive Hulu plan. So we're going to let E stand for you buy the more expensive Hulu plan. F will be you can watch TV commercial free. And then this argument has the following form. If E, then F, and not F, therefore not E. So now we're going to go ahead and make a truth table for the argument. And so here we have the two premise. And you can see that if the first one is false and the second one is false, then the if and then is true. Then the not F is true, and then of course the conclusion here would be true. Now, because the only line in which both premises are true also has a true conclusion, we conclude that this argument is valid. Now, we're going to determine whether the following argument is valid. If I have the new calling plan, then I can text my friends for free. I can text my friends for free. Therefore, I have the new calling plan. So we're going to let C represent I have a new calling plan. Let F represent I can text my friends for free. And then we can write the argument symbolically as if C then F and F therefore C. So we'll make a truth table as we did in the previous examples with columns for both the premises and the conclusion. Now here you can see that when both of them are true, the conclusion is false. So line 3 in the table shows that it's possible for both premises to be true, but the conclusion is false. This means that the argument is invalid. And so what happens here is that we have if C then F and F, and then we end up with a false in the final column. So let's go back here. This form of the argument here might be one of the common forms, and if it is, then we can automatically say that it is false. So just remember that the form of that particular argument. And then so here we have some that are invalid, if you will. And so here's the fallacy of the converse. If it's in this form, it's always going to be an invalid argument. Here's the fallacy of the inverse, and if it's in this form, it's always going to be invalid. Here we have the law of detachment. That's a valid argument. The law of contraposition, the law of syllogism, and then disjunctive syllogism, sorry. And so identify the form of an argument. Identify the form for each argument and state whether it's valid or invalid. If you want to improve your cardiovascular fitness, then you take up cross-country skiing. You take up cross-country skiing, therefore you want to improve your cardiovascular fitness. So we're going to let I represent you want to improve your cardiovascular fitness. Let C represent you take up cross-country skiing. This argument has the following form. And so this is the fallacy of the converse, which is an invalid argument. And then here's another one. If you sleep through your morning math class, then you'll be well rested. If you're well rested, then you will do well on your math test. Therefore, if you sleep through your morning math class, then you will do well on your math test. So S is going to represent you sleep through your morning math class. R is you will be well rested. W W will represent you will do well on your math test. And the argument has the following form. So this is a syllogism and therefore is a valid argument, even though the reasoning seems to make no sense, right? And that's the end of section 3.4. Thank you.